Hi, this is Professor Earth, and here I am where I live in Alaska. And normally when I do these YouTube videos about climate change, I'm telling you about their effects on Alaska and other areas. I'm talking about massive forest fires, about permafrost melt, about sea level rise or glacial melt or river flooding. But this talk's a little bit different because I'm going to talk about one of the causes of climate change. I'm going to talk about a newly discovered source of methane that's going to drive climate change and make it even worse, make the planet even hotter. And what is this new source of methane? Where is it? It's right here. It's here in Alaska. Alaska is being hit hard by global warming, but we also want to know what's causing global warming. And in Alaska, we have a young scientist known as Katie Anthony Walter. Here she is now, and she's making a big contribution. Katie's initial research was on frozen Arctic lakes. She found there were mysterious bubbles and pockets of gas within the lakes, and if you'd cut into these and set them on fire, they'd explode. It was methane. You could see the methane coming out of Arctic lakes. So these lakes make up a small percentage of the Alaskan landscape, but Katie went to a number of them. She went all over the state and found that many of them are producing large amounts of methane. Then she went to Siberia and she found more methane. So we have a huge source of methane here, but is that the end of the story? Well, no. Katie quickly realized that the reason there was methane coming out of lakes was that permafrost was thawing underneath the lake at the bottom of the lake, and the decaying of the permafrost and the organic material in it was releasing methane. But what about the rest of the state? What about the areas that aren't lakes? What about areas where there's permafrost? And in fact, here's an area of permafrost we can see in the video, this very hummocky terrain where melting ice, the land is collapsing downward into areas where the ice is being removed. Could there be methane being released in areas like this? So this became the next target of Katie's research. Katie went to a golf course in Fairbanks, Alaska, where people reported the ground was mushy and squishy. And she pierced the ground, set it on fire. Methane coming from solid ground. This was permafrost releasing methane. Suddenly the potential for more methane lakes over a much larger area became real. If we look at a map of Alaska, we see on this map the blue area are areas of continuous permafrost. The pink area below it are areas of discontinuous permafrost, where you might find ground ice mainly on the north sides of hills. Well, Fairbanks is in the discontinuous zone, so there seems to be really a lot of potential for melting permafrost generating methane. And the next map shows Siberia. So Siberia, there's another huge target for more ground ice melting and massive releases of methane. And this summer, Katie and her co-workers published in Nature Communications the results of their first study. They're looking at Yedema, which is a Russian name, for frozen permafrost uplands. They mainly were working in Alaska, where these blue dots show the locations. They can extrapolate their work to areas across Siberia using remote sensing to look for similar areas. They started by looking at boreholes and measuring methane. As they went down, they found more methane. So then they just started digging soil pits in these Yedema areas. Everywhere there was methane. A little lower at the top where it's mixing with the atmosphere, but everywhere they looked, they were finding methane being released from permafrost. Then they did more detailed studies. These are photos from their report showing permafrost mounds where the ice is melting away, leaving behind ridges and mounds in the center of the ice wedge polygons. Here's an aerial photo showing the same thing. So they put methane detectors at their field sites. They put them in the ice wedge gullies across the mounds, and they found quite high fluxes, in some cases over 700 milligrams per square meter of ground surface per day. And what's more, the fluxes were happening from all kinds of permafrost features. They did this analysis throughout Alaska, and they found the highest values over a year were from these kinds of ice wedge features that are melting downwards. But what was curious over the year is that they had higher fluxes of methane in the winter than in the summer. You'd think the warmer temperatures would flush more CO2 out in the summer, but they think that there were some processes going on in the soil that was destroying the methane, while it was being really flushed out in the winter by freezing the ground and forcing the gas out. So what does this mean for global warming around the world? Well, it means we're going to have more methane in the atmosphere than we thought, coming from Alaska, coming from Siberia, coming from thawing permafrost in these two areas. And the amount of this methane is about 10 to 60 times greater, an order of magnitude and more greater than previously thought. So this means more global warming, more forest fires in the Arctic, more forest fires in the lower 48, because methane's a very powerful greenhouse gas. And the amount of methane is going to be about 10 to 60 times greater than previously thought, coming from these Arctic regions. That's a big number. So we're just going to see more global warming than the models are currently predicting. Thank you very much. Have a great day.